as you see, it's the Anthropocene without boundaries. The human transformations of the earth, as we all know, are very pervasive. They have taken place over millennia and maybe, lakhs of years and so on. So both in terms of time as well as in terms of the interventions that humans have made with the planet, it's very difficult to kind of capture and put the Anthropocene and create boundaries, right? So there has been a lot of debate around the fact as to, because Anthropocene is a time term. Anthroposphere is the corresponding activity that has taken place by humans on Earth. So I'll try and take you through this journey where I believe, of course, that putting Anthropocene within some boundaries is a misplaced notion, and also try and take you through some illustrations of the kind of transformations that have taken place by humans on our planet. Before we enter into this discussion, let us ask the question, how does the Earth's surface work? The Earth's surface is a complex interactive system. It basically represents an interplay and feedback system between tectonics, climate, the biosphere, and now, of course, the anthroposphere. Minus the anthroposphere and minus humans, it is essentially a machine which is driven by the internal heat of the Earth, resulting in plate tectonics on which climate is superimposed, and that system derives its energy from the sun. And we know the Earth is an orbiting system. Orbital parameters change the geometry between the Earth and sun. And then, of course, various greenhouse feedbacks, volcanic emissions, they all together control the insulation that is there. And this climate tectonic system ultimately determines the composition and the characteristics of the physical atmosphere, the chemical atmosphere, the vegetation, and then, of course, in turn, the physical land surface, the chemical land surface, and then, of course, all of these produce sediment routing systems, which ultimately end up in the ocean. So minus the humans, this is what the Earth's surface is, and humans and other species within the biosphere inhabit this particular system in which there is an interplay between tectonics and climate. Now, if I take you to the little box on the black box that is there, and then introduce humans. So humans essentially are, and this triangle here represents people. Today, 8.3 or 8.4 billion people now. And then their needs. And those needs essentially come from this entire tectonics climate system on which there is habitability. We need energy, we need food, and we need water. And of course, energy, food, and water are ultimately, as well as the biosphere, particularly the plants and other life that is there. And then, of course, in all of these effects, climate begins to play an important role. And humans, because of their needs that are there in terms of energy, food, and water, of course, disturb things in terms of the greenhouse gases and consequently climate and so on. So this is, in a sense, the story. Now the questions we will try and ask. So in recent centuries particularly, and this is not a mathematically operable kind of equation, it is just an expression. A here stands for astronomical characteristics in terms of the orbital parameters of the Earth. G stands for the geological factors. I stands for the internal dynamics, essentially in terms of plate tectonics. And these A, G, and I were what we showed in the interactions of that interplaying system between tectonics and climate. Superimposed was the triangle of H with all these needs that they have in terms of energy, food, and water. So now let us look at two terms. Anthroposphere is the kind of activity, the sum total of all activities that humans have made for time immemorial, no boundaries in terms of time, ever since the human species are there, including modern humans. And then the Anthropocene is a more time restrictive term, but they're very kind of interlinked. Human transformation of the earth and its fluid in envelopes is what immediately strikes the mind the moment you talk in terms of the anthroposphere or the Anthropocene. Now, one of the significant questions from the geological perspectives was that when did it acquire global significance? Was it at the time when the first use of fire took place? Was it at the time when the first agricultural settlements came? Or was it at the time of the beginning of the industrial era? So to answer this question, essentially, people began to look at the flow of energy. And they've gone back right up to 3.7 GA. Remember 3.7 GA. And that's when anoxygenic photosynthesis started. And then that is the circles here represent the energy capture or the energy that is being utilized by those biological systems. Then you have oxygenic photosynthesis, starting with the waves of oxygenation of the atmosphere over here, 2.7 GA. And then you have land plants come at about 470 MA, more energy being utilized by the biosphere. And then, of course, finally, we come to where humans begin to, or human-related species begin to use fire, essentially. So the impact is very low in comparison to the natural biosphere over here. So you can see there's a large difference between whatever the human-related species were doing when the Paleolithic fires use started and between here. And then, of course, the green ones basically tell you the amount of energy that is being utilized by humans and what the rest of the biosphere is utilizing, essentially. And then you will see finally, by the time we come to the beginning of the industrial era, with the usage of biomass and fossils, and this black part over here and the green part essentially is the use of wood and fossil fuels beginning, and that begins to equal the rest of the biosphere. So human agency is slowly trying to, overwhelm the forces of nature. So this is essentially the long and short of this story. And you'll see here that there are estimates by a professor from Oxford called Yadvinder Malli, and global land biosphere metabolism is about 150 terawatts. Pre-agricultural human extended metabolism is a very small fraction, 0.002%. 2% of biosphere, pre-industrial human extended metabolism. Modern became about 25 terawatts, about 17% of that total, essentially. And the global UN projections for 2050 are about 48 terawatt, which is 32% of the biosphere. But if we continue to kind of use the energy which is being utilized by global China or global US, if we want the entire world to come to these standards, then it's 60 terawatts or 180 terawatts actually. So that'll be 120 times. If we adopt the US standards of energy usage and continue to do it until 2050, then we will be at 120% of that. So this is the story, this is the worry, and therefore, now what has happened is well recognized that the human agency has disturbed the Earth's surface systems. It has impacted several disciplines: Earth system sciences, life sciences, agricultural sciences, engineering sciences. It has impacted the social foundations as well in terms of governance and policy frameworks, economics, politics, governance, sociology, political ecology, socio-hydrology, art, cinema, literature, international laws, ethics. It's kind of, pervasive now. And you can see, as evidence of that, GSA Today, which is a popular magazine of the Geological Society of America, carried something like, "Are we now living in the Anthropocene?" on its front page. Even The Economist, actually, which is not a geosciences journal, also has a front page contribution on "Welcome to the Anthropocene." And this was happening almost 15 years ago. So from 15 years ago, all this has started. And if we kind of delve a little bit more and go back into the historical evolution, the idea that Anthropos, or the human agency, has been very active in disturbing the Earth's surface has been around for more than a century. But it was actually resurrected by Paul Crutzen, the Nobel laureate, and it all started in a meeting in 2000, the IGPP Scientific Committee meeting that was happening in Mexico. And he said at that time, stop using the word in the meeting, Holocene. We are not in the Holocene anymore. We are in the Anthropocene. And that is when the popularization began, actually, or resurrection of a concept that was already there. So this sudden realization that humanity had very recently stumbled into a new geological epoch of its own making, the Anthropocene, created reverberations that continue to shake not only the world of science, but that of all of scholarship, now spilling into political and economic thought. And that statement of his made a very strong impact to everybody who was present in the room. In Nature, in the important magazine, Crutzen wrote an article, which is a one-page article, and then, of course, there was a special issue in 2011, and the establishment of the Anthropocene Working Group took place. Then, of course, there was a special volume, as I said, in 2011. And then now there are at least 3 journals which are exclusively devoted to the Anthropocene. So you can see the quick development that has taken place in the last 15 years or so in terms of both academics, in terms of its strong interdisciplinarity. The article written in 2002 is shown over here. My cursor is moving over it. It's called Geology of Mankind. And the box over here says the Anthropocene, essentially. So he defined and kind of put it in the context of the turn of the millennium. And that is where we were in the year 2000, published in 2002. But again, we must give a tribute to this person, Antonio Stoppani, because he was the person who had actually said earlier, much earlier actually, that humanity is a new telluric force which in power and universality may be compared to the great forces of the earth. So the same concept resurrected in a modern context, and this was published in the Corso di Geologia in 1873. So we have seen that the Earth is moving out of its current geological epoch. If you go to the time scale, the youngest epoch will be the Holocene. Humanity is largely responsible for this exit. Humanity has become a global geological force since the 50s, and we must adapt our worldviews accordingly. But what are the landmark developments that have taken place which has brought about this, essentially? So we can see, if we go back about 8 to 10,000 years, you will see the beginning of urbanization and anthropes subsuming natural landscapes. That is essentially talking about the beginning of agriculture and settlements. Jethro Tull and mechanized farming, 1701, because then there was extensive use of agriculture. Industrial scale use of fossil fuels, 1709. Mendel and genetics, 1956. Concentration of humans in huge cities, post-1900. Haber-Bosch process, nitrogen fixation, 1909. Then the Green Revolution, 1960s, and perhaps much more in the later decades. Down below, what we have shown is essentially the kind of benign climate conditions that took place, that were prevailing during the Holocene, the last 11,700 years. But remember, within the Holocene, the climate shifts were short-lived, there was a dryas event over here, 8.2. There was another event at 4.2. There were also some other events, centuries-long events over here in terms of MCA and in terms of the LIA. So, but this was largely a benign climate in which, humans could flourish. And that climate change is also part of the story of the Anthropocene. Now, a debate has ensued. Where do we start it? And should we start it way back? And there is a multiplicity of views. However, there is a very influential kind of thinking that it should be placed at about 1950. Initially, Crutzen had placed it at the beginning of the industrial era, the Industrial Revolution and global atmospheric change. And that was what he had suggested, about 200 to 300 years. And we have seen the landmark developments in the previous slide, which probably led him to place the boundary here. But subsequently, a lot of influential workers, Williams, Stephan, Crutzen himself actually changed his and joined this group. They were essentially talking in terms of 1950s with dramatic changes taking place. We'll come back to that. And there are many other suggestions also. Beginning of agriculture is another suggestion that is there. And then even earlier suggestions are there. But these three are the subject of intense debate. So the later Holocene, you have anthropogenic landscapes everywhere. Should an Anthropocene be separated from the Holocene? When does the Anthropocene start? Should it be at the time of agricultural and land clearance? Should it be the beginning of industrial era? Should it be when nuclear testing took place and you have records of that, stratigraphic records of that? So there are multiple ways of looking at this. There are people who even are willing to go back to the early hominids, essentially. They go back to 1 million years. But then, of course, there is the Neolithic Revolution, the Industrial Revolution. And most people, there was a suggestion that we should have a term Paleoanthropocene to describe all that, and that it should largely be confined to the post-industrial revolution period, which is about 200 years. So this debate was there. So essentially, if you can look, this column on the left is the geological time scale. The one in the middle, there's a question mark there. What is the kind of time that you want to slice out of the Holocene, essentially? And a third suggestion where you want to push the Holocene into the Pleistocene epoch and then separate an Anthropocene. So this was made again in a Nature paper, Lewis and Maslin in 2015. Now, because of all these debates, around 2010, the Anthropocene Working Group was set up by the Subcommission on Quaternary Stratigraphy of the International Commission of Stratigraphy. And the Anthropocene Working Group prepared a proposal. I will not go into the history. It worked for several years, 12, 13 years. And then, of course, there was a proposal from the AWG that it should be placed and should coincide with what they called the Great Acceleration, or the changes that have taken place post-1950, a time when the global stratigraphic signature of human impact is distinct from the Holocene epoch or the previous Pleistocene glacial interglacial cycles. But, and more recently, the Anthropocene proposal was defeated, 12 votes against, 4 in favor. So there was an overwhelming defeat, 12 versus 4. And when a governing body of the International Union of Geological Sciences voted down the proposal to name a new epoch in Earth's history, this is the rebuttal again from that group of 4. It ignored conclusive evidence that for the first time, a single species, humans, have fundamentally altered the planet. So now that we have introduced the term the Great Acceleration, let me kind of dwell a little bit about that. This is the famous diagram which Bill Stephan diagram, which is very often used, where the great acceleration is this steepening part. You look at any one of these curves, at about 1950, they show a very strong steepening, essentially. Whether it is parameters like the chemistry of the atmosphere, whether it is the population, whether it is the total real GDP, whether it is the damming of rivers, whether it is the use of water, use of fertilizers, ozone depletion. I won't go through the list, but anything that you look at, essentially there's a steepening that is taking place post 1950. Now, this has been captured in a significant paper again by the group that was kind of pushing the case for 1950 and the great acceleration. And this can be explained by looking at these three graphs. You can see that is the baseline data, and that is where the acceleration takes place, 1950 onwards. Now, the first graph, as you can see, is the global population in millions. The second graph is the global energy consumption. The third one is the global productivity, GDP. 1950 is the square at the bottom from where the acceleration starts, and they've essentially tried to say that the Earth has moved out of its current geological epoch, that is the Holocene. Humanity has accelerated development around the globe, notably in the West, and the West is responsible for this shift. Humanity has become a major geological force and has overwhelmed the forces of natural agencies. They also proposed the Crawford Lake, Ontario. I mean, a lot of GSSPs, I think there were 12 candidates, and the GSSP that was proposed was this one, which was from the Ontario Lake. However, there is a strong group of people rooted in stratigraphy who believe that it is not wise to call this an epoch and place the boundary at 1950 within the geological time scale, and that is why it was voted out. And they suggest that it should be taken as a time transgressive event and not as an epoch. Now, this is a complex chart, and I will not go into the details, but this proposal is by Gibbard et al. Now that we have understood the kind of debate around time, I want to move on to talking about, the issue of sustainability. In my view, sustainability has to have a perspective of timefulness. Whatever is happening on the surface of the earth is now being determined both by natural agencies and the human agencies, and time is involved in it, as we have seen. It may be 200 years, it may be 50 years, it may be 8,000 years, but we need to have a time perspective. The time perspective is called timefulness. Civilizations, agriculture, and the spread of crops. This is one thing that has happened. So you have maps of planets which have been, and of the planet, which part of the planet has been used for how long? Which river has been used for how long? What is the level of human water interference and the global crisis of water? How much is the terrestrial hydrosphere disturbed? And so on. So I will largely focus around water now. So there are some interesting papers actually, and you can see over here, this is a map of what is called the used planet. And this essentially deals with the ancient anthropogenic biosphere. We looked at the metabolism of the energy exchange that takes place between the biosphere and the environment essentially. And you can see that the period of first significant use is roughly about 8,000 years. That is in black color, you won't find too much of that color. But let's focus a little bit on India actually and see that because India, we have ancient civilizations. You can see these brown colors over here, 5,000 to 8,000, 3,000 to 5,000, and 2,000 to 3,000. So we've been using our environmental resources for a long time. Of course, the bulk of the people always occupied the river valleys, and therefore, as we know, whether we are a river valley civilization, be it the Indus Valley civilization, or be it the Ganga Valley civilization, or the rivers in peninsular India. Now, the human transformation of the biosphere and biodiversity is one of the first things that have taken place extensively. As I said, irrespective of whether we talk of 200 years or whether we talk of 50 years, we need to go back to look at transformations of the biosphere, and for that, you need to go to the beginnings of agriculture and the beginnings of the first civilizations that practiced agriculture and then developed urban centers once agriculture flourished. In the words of Mali, again a very nice sentence over here, agriculture is the colonization of ecosystems, where you destroy the biosphere, the vegetation, and you essentially begin to practice agriculture, convert biomes into anthropes. This is a map, again, in the same vein, which is about the spread of agricultural crops, particularly during different periods of time. The yellows are 12,000 to 8,200 years, the centers of crop domestication, the diffusion pathways, and then also the greens represent the diffusion that took place between 8,200 and 4,200 years ago. So the anthropos now, instead of having biomes, these are really converted into anthropogenic biomes, and therefore the name, to shorten it, has been given as anthropes. So we are hardly looking at biomes today. I mean, if you leave the deserts alone, or if you leave areas where very little vegetation is there, then most of it is converted into anthropes. Now, once you have created, and that means there is dramatic land use change which has taken place. And once the land use change takes place, then you are impacting the water resources and you're disturbing the terrestrial hydrosphere, essentially. Now, the moment we talk in terms of the disturbance of the terrestrial hydrosphere, I also want to introduce the idea of planetary boundaries. And you can look at planetary boundaries here, the 9 planetary boundaries: climate change, ocean acidification, stratospheric ozone depletion, novel materials, the phosphorus cycle, nitrogen cycle. And here is the global freshwater use, which I am going to concentrate upon, because in my view, water is fundamental to all the biosphere, essentially. So everything else is okay. I mean, still not okay, but those planetary boundaries have to be dealt with and have to be kind of strictly monitored. But water then, of course, becomes the most fundamental even of those 9. Let us look at the disturbed terrestrial hydrosphere, and you can see the ecological footprint that has already taken place, both in terms of gray water footprint, the blue water footprint, which is essentially our surface water and groundwater, that is the available water resources, and then the green water, which is there and which has been impacted greatly because of the land use over these past several millennia, actually. Green water is essentially about the water which is there in the soil moisture and in the biosphere, the plant system. Okay, and so now let me take you to, so we've looked at land use and we have looked at the way land use has changed. And then I came from land use to how the terrestrial hydrosphere has shifted. And now let us try and look at the way in which how civilizations have impacted rivers, because a lot of our civilizations have really been around river valleys. And you see, there is a period of about 15,000 years or so when you have minimal river effects, essentially. Then, of course, you have minor river effects starting in the pre-Holocene time, in the latest Pleistocene. But then the onset of agriculture in the early Holocene, the agricultural era, then you come to the irrigation era, then you come to the engineering era, and you come to the technological era. So you can see that the use of rivers has been immense, essentially. And as a consequence, the rivers are no longer what they were, actually. There are no pristine rivers, so there is hardly any river which is, there are a few in the wilderness, essentially, which are in Siberia or in Alaska, but apart from those, most are impacted. How do we impact rivers? The biodiversity gets impacted, the pattern of floods gets impacted, How do we impact them? We create engineering structures, we create hydropower plants essentially. So the fluvial systems are no longer natural fluvial scapes, but stand converted into what we call the fluvial anthroposphere. And the fluvial anthroposphere is the most sought after resource by human societies. Leads to conflicts, leads to multiple land uses, leads to different problems in terms of crossings, and then, of course, leads to issues of pollution. And in a country like India, we don't need to be told about these things. We feel and see these things all the time. So, people have begun to look at the level of stress on the world's big rivers, particularly, which is our most important resource. So, the question is, large river systems, how stressed are they? They support civilizations, and currently about 3 billion people are being supported by rivers. The anthropogenic stressors include large-scale damming, hydrological change, pollution, introduction of non-native species, sediment mining, and other issues as well. And many of these are actually irreversible transformations. And the challenge in front of all of us is how to sustainably manage and establish these rivers. So the human water interference started with land conversion, then fed into the climate change story, apart from other things, essentially the fossil fuel story, and that also led to changes in the water use. All of that added up to the climate change story, and so the global water cycle is disturbed. I'm just illustrating one of those 9 boundaries, planetary boundaries. You can see how society is being impacted negatively. 1.8 million deaths from water pollution, 4 billion live with severe water scarcity, 80% live in high water risk areas, agricultural regions depend on failing non-renewable groundwater. And ecosystems problems are there are other hydrology problems. But you can see now, I just wanted to break this up for you. Global water, when we look at global water, it is very difficult because there are so many components. Of course, even if you leave the deep ocean and surface ocean, but they're not potable water systems, they are not used for irrigation. So you have the terrestrial hydrosphere. Terrestrial hydrosphere is composed of the ice sheets and glaciers impacted by humans, non-renewable groundwater impacted to a very low degree yet by this thing, renewable groundwater impacted by humans, permafrost impacted by humans, fresh lakes impacted by humans, saline lakes impacted by humans, soil moisture impacted by humans, wetlands impacted, atmosphere impacted, atmosphere over the land impacted, seasonal snowpack impacted. So almost all components stand impacted. I'll skip this. However, despite this kind of intervention and interference that we have seen over this period of several millennia, starting with the settlements and agriculture, the human domination. You see this again in HHU science paper, which says human domination of the global water cycle absent from depictions and perceptions. We have gone and actually impacted all these systems in a major way. Yet, when we talk about the global water cycle, we do not worry about it. And so this paper essentially looked at 465 publications and then said that any sign of humans was not there in 23%. Human integrated with water cycle only 15%. Blue water use only 10%. Green water use only 3%. Grey water use only 2%. And climate change only 1.4%. So this is the level, and this is a fairly recent paper essentially. Another thing which is impacting through rivers essentially is the relative sea level budget. And here we are talking in terms of, I'll take you to this equation here because we know that sea level is rising. we also know that we are actually trapping sediment behind dams and engineering and other engineering structures. Consequence is that, the only thing, if you look in this equation, is if you do not allow sediment input into the deltas, aggradation rates drop essentially. That is the positive term. Anything else is about inundation and coastal flooding, essentially. Eustacy is about coastal flooding. Compaction, natural, is about coastal flooding. It accentuates coastal flooding. Anthropogenic activity, again, by extraction of groundwater, sediment mining, etc., all of that, again, impacts and leads to subsidence. So all these three terms are negative terms. They lead to subsidence, and so also subsidence induced through long-term geological processes. The only positive term is A, and our activities are essentially lowering A, and that means that we go, the RSL goes down, the relative sea level goes down. We are in minus in the budget over here, and that is another consequence of all these large dams. This is an example of the previous slide, a live example where Mekong Delta in these countries like Vietnam, Cambodia, etc., are going to be impacted very strongly. And so all the budgetary requirements are shown over there. I'll not go into the details, but this is about climate-driven sea level rise. It's about anthropogenic-induced subsidence. It is about sediment starvation driven by shifts in climate extremes. Both climate is impacting it, along with a combination of sediment trapping behind hydropower dams and intense sand mining. So, looking at all of this, one of the key challenges in front of us is in terms of the resilience of large river basins. There's a map of the world where large river basins, about 35 of them, are the fundamental resource for humanity, and how to look at that. Now, if you look at this, climate change is one thing which is impacting the river systems at the global scale, at the regional scale, at the semi-regional scale. Then there are local stressors, which are environmental stressors by way of what engineering structures we have put. And these stressors come and intersect on already the lowered resilience because of the climate change. What are the factors? It's climate change, it is dams, it is sediment mining, it is groundwater extraction, it is subsidence, it is greenhouse gas related sea level rise, land use change, fragmentation in terms of biodiversity, pollution, non-native species introduction, water abstraction, interlinking of rivers. All of these things have to be, kind of ultimately take you to the story of examining large river basin resilience. So I've tried to illustrate all this, and I would like to kind of move to an example. Now, this is an example of what happened in India on August 2008, essentially. I think it was the 18th of August. An Anthropocene incident in the Kosi fan in North Bihar. You know, the Kosi is the sorrow of Bihar. And there was a book also written by a local journalist, Trapped Between the Devil and Deep Waters. So this is an example of how humans induced river disturbance created havoc. So this is the Kosi fan, essentially. You can see the Kosi fan, a blow-up of the Kosi fan. It's an avulsive system, which means there are sudden shifts of the course of the channels, essentially, over the last 200 years. Hello? Is that okay?
Yes, sir, that's fine. Please continue.
Okay. Now, you can see a map of the Kosi fan. Now, what has been done is you can see the Western Afflux Fund. This is an embankment, 1955, 1956. Then there is another embankment over here, the Eastern Afflux. So the Kosi tiger, let me call it, is straight-jacketed and captured and put into this, band over here, essentially. As I said, sans boundaries. We have created these boundaries, humans. And the Kosi barrage is over here, essentially. And 12 kilometers upstream of this, there was this huge disaster, the breach of the embankment. This was the Kosi mega fan, essentially. And until 18th August 2008, this is where the channel was flowing. And then it jumped 100 kilometers across it. It just moved out, right? Why did it move out? There was a breach upstream of So the embankment breach at Pusaha, 12 kilometers upstream of the Kosi barrage. It was a 1.5 kilometer long breach. that developed over a few days and resulted in a sheet of water 15 to 20 kilometers wide and 150 kilometers long. The channel bed elevation was about 4 to 5 meters with respect to the adjoining surface, which means the channel was at a higher level, the channel bed, than the adjoining area. The maximum eastward lateral shift was about 100 kilometers. The breach took place because of the failure of the embankment and had nothing to do with the barrage, which had a much higher design capacity. 5 districts, 2,500 villages, and 4.8 million people were affected. So this is some work that we did essentially. So this is where the Kosi is, right? And the new channel, it broke from here essentially. It broke the embankment, and then all this area was inundated. So, and you can see that there is an area of about, it shifted around 100 kilometers. And then, of course, kind of spread sand, agricultural land was converted into wasteland and so on. Now, this is the work of humans. This is not the work of nature, essentially. So there is a huge amount of problems in our country and elsewhere related to the terrestrial hydrosphere. It may come from the melting of glaciers. It may come from the rapid groundwater depletion, particularly in northern parts of India. We have to decouple climate change-driven changes in the hydrological systems from human stressors. We have to look at the changing patterns of extreme events. We have to look at the contamination levels of renewable groundwater. We know the arsenic story in West Bengal and Bangladesh. We know of the novel and emerging contaminants from agriculture, industry, and domestic activity. And then there is, of course, the problems of increased temperature and intermittency of flow in arid and semi-arid regions. There is the issue of submarine groundwater discharge. There is the issue of changing sediment yields because of dams and other structures. These are all interlinked issues, essentially. And then I ask the question, is it now time for new water governance structures based on limits, justice, and wisdom, where we look at many of these things in a much more integrated way than in isolated systems? So I've tried to use the water boundary as the planetary boundary on fresh water to exemplify the case for the anthroposphere and the disturbances. So the planetary, I'll try and conclude now in the last part of this talk, carrying capacity and limits to growth, guardrails and tipping points. This is what you want actually, because you want a safe operating space for humanity. And what is being realized is that space has become to a great degree, unsafe, essentially. So you can see that the limit cycles for long term, for a million years, are the glacial interglacial limit cycles, where essentially the Earth's orbital parameters are the main controlling factor. It is the Earth's precision, it is the obliquity, and it is the eccentricity. Now, so the Earth has shifted now to somewhere over here. This is a diagram from Bill Stephan again, and then it requires to be, the human emissions, the way things are going, and a temperature of 2 degrees, human emissions in terms of the carbon dioxide and methane, and we want to move from there to bringing the Earth. I mean, we are already moved out of there actually, right? So we've crossed this hump, and we want to place it here. The fear is that if we go on in the way in which we are, and there are no disruptive technologies to change the development that take place in our search for higher GDP, then we might end up in the hothouse Earth, essentially. These are the limit cycles which have prevailed for more than 800,000 years. And so we need to worry about these planetary boundaries. And then, of course, we want to keep ourselves from the hothouse Earth. So therefore, the question is that all of this gets related in some way or the other to the sustainability, the UN sustainability goals, 17 of which are there. So should we not, as quaternary scientists, be engaged in focusing on delivering science-informed knowledge and translating this into providing environmental services, solving environmental problems, devising environmental management strategies for the future? Have we done enough to provide deliverables to different segments of society for the purpose of resource security and environmental security together against the background of these sustainable development goals? So we can see that ultimately, we can't fight with the sun. It will do whatever it wants to. We can't fight with the volcanoes because the internal dynamics of the earth will go on irrespective of us. What we have done is, dig out the fossil fuels and the energy that is there and disturb the biogeophysical systems that occur here and have made them integrated with the knowledge systems and the energy systems over here, including the greenhouse gas emissions. And therefore, the path really, is to look at the geosphere and the biosphere together, link these and link that with the anthroposphere also. The anthroposphere systems, as I said in the beginning, in the first slide, is about energy, it is about water, it is about food, essentially. And that leads us to a lot of resource extraction, production and consumption, energy systems. They are dependent upon knowledge, science, technology. Their management is dependent upon institutions, political economy, and they are also dependent in many ways on cultures, values, and beliefs on this vast planet, essentially. So all of this needs to be married together, actually, and to be understood. People are attempting to do so in quantitative models, in different kind of models, which I understand very little. So this is about planetary stewardship. At a social level, we have to deal with poverty, infectious diseases, the use of fossil fuels, biodiversity loss, desertification, ocean dead zones, pollution, ozone, ocean acidification. And then, of course, there are other issues like water management, sustainable trade, sustainable cities, food security, forests, economic equity, renewable energy, education, population. Our challenge in the 21st century is to navigate a transition from endless rapid growth to a sustainable global state while providing well-being for humanity and living space for the rest of the biosphere. Now, that is a very profound statement. Remember, we have to provide living space for the rest of the biosphere. Have we done that? This will require extensive innovation both in technology and in governance. So the total human social metabolism essentially has been captured here. The emergence of Homo, fire and meat-eating, Homo sapiens, expansion out of Africa, spread of farming, European conquest of the Americas, the Great Acceleration. And we are now beyond the Great Acceleration, worried about where are we going, +2 degrees, +4 degrees. Are we going to go into the hothouse Earth, as I said a little while ago? Or are we going to go into a safe Anthropocene? Or how long will we endeavor to be in what we are, the good Anthropocene? And this lady is also Nobel laureate, along with Paul Crutzen. She was responsible for Elinor Ostrom was responsible for the report on Planet Under Pressure, which was submitted in 2012. And this is a quote from there. Centuries from now, the defining event of the 20th century may not be the great wars, the battle of ideologies, or even the Industrial Revolution. It may well be the ascendancy of a single species, that is us humans, to become the dominant geological force in a single human lifetime. So that's a very profound statement if you think and ponder about it. So my final slide is, there are books now which talk a lot about this. There's a book by on Breaking Boundaries by Rockstrom. There's a book by Ian Golding, which is called Is the Planet Full? There is another book called The Big World, Small Planet. The fight is on for a safe and just space for humanity. And cultures, values, beliefs are different in different parts of the world. And we continue to have, our meetings of COP and so on and so forth with different viewpoints, and convergence, something which is difficult to find. But Wills Durant's statement reminds us that we must come together and converge, because civilizations exist by geological consent, subject to change without notice. And humans need to keep this in mind. Thank you very much.